Hey students, in this video we're going to cover angle side angle congruence and angle side congruence. Our objectives are to complete proofs using angle side angle congruence and to complete proofs using angle side congruence. All right, so the first congruence we're going to cover in this video is angle side angle congruence, and that occurs when two triangles share two pairs of congruent angles and a pair of congruent sides that is between those same angles. So we call that side an included side. So we can see that we have angle R marked congruent. We have angle P marked congruent to angle E. Angle R is congruent to angle D. And we can see that side that's marked is between those two angles. That's what makes it angle side angle. The side is literally between the two angles. And so our proofs are going, whenever we write our proofs and we label our diagram, at the end, we should see we have two angles marked congruent, and the side between those two angles should be marked congruent to the side in another triangle. So our first example is we're given, hold on a moment. So I don't know where this came from. This should be prove triangle ZYX is congruent to triangle. I have no idea how that got there. We're going to call that GYX. And all right, so let's get started. So our statements, let's see, we are given XY bisects angle ZXY. So remember, if you see something bisects, it means it divides that figure into two congruent smaller halves. So if XY bisects angle ZXY, that should be ZXG. Mr. Martin, you're full of mistakes. This should be bisects angle ZXG. And so that's going to mean that angle ZXY is congruent to angle GXY. So our first statement is angle GXY is congruent to angle ZXY. And the reason is going to be definition of angle bisector. I'm also fine if you just put angle bisector. That would be fine as well. The next thing we know is that XY bisects angle ZYG, which means that angle ZYX is congruent to angle GYX. So we know angle GYX is going to be congruent to angle ZYX. And the reason, again, is definition of angle bisector. So now we have an angle, and now we need to get that side between the two of them. Unfortunately, XY is going to be congruent to YX, and that's going to be because of the reflexive property. And so we're going to mark that side congruent to itself. So if we look at, for instance, triangle ZXY, we have an angle, we have a side, and we have an angle. And so that's going to make it angle side angle congruence. So we're going to say we're going to put our prove statement here. We're going to have triangle ZYX is congruent to triangle GYX, and the reason is angle side angle congruence. So again, we took our given information, used that to label our diagram, and after we labeled our diagram, we wrote the reason based upon our markings, which in this case was an angle, a side, and an angle. For example 2, we are given that FE is parallel to RQ and D is the midpoint of FR. So if FE is congruent to, if FE is parallel to QR, we know that. So that means that this segment QE acts as a transversal. And remember, anytime we have parallel lines, then the angles interior to the triangle are going to be alternate interior angles. So the first thing we can say is angle FED is congruent to angle RQD, and that reason is alternate interior angles. Next, so we're trying to do an angle side angle proof, right? So next we can actually make another pair of congruent angles. So since FE is parallel to QR, we also can make a connection using FE, FR, and QR. And I'm sorry, we have D is the midpoint of FR. So we're going to use angle EFD is congruent. So angle EFD is congruent to angle QRD. So we're going to put that in. Actually, let's use that in our first spot. So let's take this one out. We'll put in the blue one that we wrote. So we're going to use angle EFD is congruent to angle QRD. And that reason is still alternate interior angles. The next thing that we know is D is the midpoint of FR, which means that D divides those into congruent segments. Let me clean up my diagram a bit. So let's just put the markings that we have in our statement. So we have FE is congruent to, EFD is congruent to QRD, and that segment is parallel to that segment. And so D is the midpoint of FR, which means that FD is congruent to DR. So we're going to get segment FD is congruent to segment FR. And that reason is definition of midpoint. Next, if we're going to do an angle side angle proof, notice we have these vertical angles here. So we're going to get angle FDE is congruent to angle, so we said FDE, so we're going to say R, that's a D, so RDQ. And that's going to be because vertical angles are congruent. So we're going to say vertical angles. And so now again, we have an angle, we have a side, and we have an angle. And that's going to mean that triangle EDF is congruent to triangle QDR. That's a D, so QDR. And the reason is angle, side, angle. All right. Next, we have angle side congruence. And that's going to be when we have two angles congruent and the side is not between those two angles. So we have an angle, and we have a side. And notice the side is not between the two angles. Same thing here. We have an angle, and that side that's marked congruent is not between those angles. So in this diagram, we're given that HG is parallel to CI. So HG is parallel to CI. And we know that angle GHI, so angle GHI is this angle, is congruent to angle ICG. So we have that angle. So we're going to write that in. First, we're going to write in angle GHI is congruent to angle ICG. That reason is given. And we're going to use those parallel lines to make another angle relationship. So since HG is parallel to CI, What that means is that this GI acts as a transversal. Let's highlight that actually. Let's go with green. So we have HG is parallel to CI. So the GI acts as a transversal. And that means that angle HGI is congruent to angle CIG. So angle HGI is congruent to angle CIG, and that reason is going to be they are still alternate interior angles. So now we have two congruences. Let's put two arcs on this so that we don't confuse them with the blue angles. So we're going to put two arcs. And next, they share this side GI. So we want to have GI is congruent to IG. And that's going to be the reflexive property. And so now we have an angle, and we have a side. And the side is not between the two angles. So we're going to get triangle GIH is congruent to triangle IGC. And the reason is angle, side congruence. Okay. And the last example, we have SR is parallel to YZ, and T is the midpoint of YS. So let's see, SR is parallel to YZ, so SR is parallel to YZ, and T is the midpoint of S. So let's use that first. So if T is the midpoint of S, that's going to mean ST is congruent to YT. So we're going to get segment ST is congruent to segment YT. And that's going to be because of definition of midpoint. So we've written one congruence. We need to come up with two more. Unfortunately, these parallel lines are going to help us. So if we highlight, so we get SR is parallel to YZ. So then that means that this line SY is a transversal, which is going to give us a pair of congruent angles. So we're going to get, write a different color. We're going to get angle RST is congruent to angle ZYT. So angle RST is congruent to angle ZYT. And that's going to be, again, because they are alternate interior angles. And we can highlight this other transversal that connects SR and YZ here. And we get another pair of alternate interior angles. This time that's going to be angle SRT is congruent to the angle. So we said SRT. That's going to be congruent to YZT. So angle SRT is going to be congruent to angle YZT. And those are also alternate interior angles. And so now again, we have an angle, and we have a side. And again, the side is not between the two angles. So we're going to get triangle SRT is congruent to triangle YZT. And the reason is angle, side congruence. All right, guys, that concludes our video for angle, side, angle congruence and angle, side congruence. In both instances, we have two pairs of congruent angles and one pair of congruent sides. The difference is for angle, side, the side is not between the two angles, and for angle, side, angle, the side is between the two.